Alright, how's it going, guys? Today I'm going to be going over how to do 4 variable K-maps. Um, by this point, you should know like a little bit more in depth about K-maps. If you don't, you should go watch a video. If it's not on my channel already, go watch it on a different channel. So, the preliminary stuff you should know is how to build a K-map. I'll kind of go over that again, and you should know what grade code sequence is. But other than that, I'll pretty much cover all you need to know about how to do a 4 variable K-map. So say we're given this this bit of information about our minterms. So pretty much, okay, what this is this function is, say we have a truth table with, if it has 4 variables, and we'll have 2 to the 4 rows, which is approximately 16 rows. So think about, we have 16 rows, and these are the 1, 2, 3, 4, 5, 6, 7. I think it's 7. The 7 minterms. So pretty much what that means is these are the 7 times that truth table outputs true, or 1 in our case. So just think about it like that. So say you have a truth table. These are the times that the truth table prints out true when these conditions are met. So when we first get something like this, we first build our K-map. So what do we have? We have A, B, C, D. We have 4 variables, so it's a 4 variable K-map. So I'm gonna have to draw this pretty big. So we're gonna have a big square for our K-map. And I have this little thing that pops out, and it helps me figure it out. So we have A, B, and C, D. And then we have our grade code sequence. So it would be, for us, it would be 0, 0, 0, 1, and then 1, 1, and then 1, 0. And this, if you don't know already, is grade code sequence. And you can do the same for the top, because we have 2 variables on the top too. So we have 0, 0, 0, 1, 1, 1, 1, 0. I do this pretty big, but it's fine. And then you're going to make a grid thing for, so each X has a Y and so whatnot. Just make the K-map. And this is pretty simple. If you don't know what I did, just like try to look back on it and just try to understand it, but it's pretty simple. So then we're going to go through and just fill in all our truths. So A, B, C, D as all zeros is right here, this first one. So we have a 1 here. This other one, not A, so we go down to where A is 0 and B is true, so the second row. And then we have not C, but D as 1. So not C, and then so D is 1, so that would be right here. What's next? We have not A and B, so not A and B. So we're over here. Let me use a different color so you guys can kind of see where I'm going. So not A and B, so we're here. And then we go down to the column of not C, not D, which is easy. It's 0, 0, so we're right here. Go back to black. Here. And to quickly go through it, I hope you guys get the hang of it. I'm just going to fill in the rest of the ones pretty quickly. Just think about it like, okay, so A is 0. You're just looking at each one of your midterms up top right here, and you're going through and being like, all right, not A, not B. You're just filling in the correct places for everything. So I'm just going to fill in the ones because I know where they belong. And I'm going to switch colors. Okay, so now once you, this is like the simplest part, where you've built your truth table, you've built your midterms, I mean, and then you fill in the gaps of your K-map with the midterms that point out true. So we have 4, 5, 6, 7. We have 7 ones, which makes sense because we have 7 midterms from our truth table that all output 1. So now, all right, one thing you have to remember is you can only group. So what you're attempting to do is minimize your problem, minimize what you can do with this. So remember, when you're minimizing, you can create groups such as like, oh, I want to group these 2 together, I want to group these 2 together, but like you're like, oh, how do I group these 3? Like they don't match. That's the great thing about K-maps. They kind of have a napkin like feature to them, where everything is rounded, you have to assume. So one important rule is, remember, you cannot group anything that's not 2 to the sum number of elements. So I can't group 3 1s together. I can't group 1 1 together because if you start at 2 to the 1, that equals 2. 2 to the 2 equals 4. So I can only group, if it's 2 to the something, then I can group it together, if that makes sense to you guys. So I can group these 4 together because they're right next to each other, and it makes sense for me to do that because they probably share something. And then what's a cool component is, remember, it's a napkin-like feature. So just imagine me taking this whole grid and crumbling it up into a napkin. That means each side is connected. So like these sides, they're all connected. And I'll illustrate the next grouping you can do is every single one can go like this. So like I said, a napkin-like feature. So there's 4 at each corner. And remember, in K-maps, you can overlap. So I can overlap what I'm working with. And remember, it's 2 to the 2. So there's 4 yellow ones, right? So that means 4 are in this specific minimized minterm. So I've thus created this is the best way you can minimize this K-map pretty much. And now I'm going to do the final step, which is getting an equation. So you're looking at the equation at the top, right? The long 7 minterm one. I can reduce that to almost literally a 2-element K-map, and I'm going to do that right now. So pretty much what you're going to do is, let me go back to the old color. Pretty much what you're going to do is you're going to look at the orange one. All right, what do all the 4 ones in the orange one have all in common? What do they all have in common? So you can look at it for a while, and you'll see that in all of them, A is not true. A is 0, as well as C is 0. So that's my first midterm. And that's only true for those 4 ones. So let me write that down. So not A, because as you can see, if you look closely, not A, 0, 0 here, and 0 here, and then not C. C is the first number, so 0 here, 0 here, and that's not the case anywhere else. It's just for these 4 ones. So that's why we picked that midterm for that specific square. And then for the ones on the corners, let's take a look and see what makes them like match. So first we can see that for all of them, B is 0. If you look closely, B is 0. B is 0 there, B is 0 here, B is 0 here, B is 0 here, B is 0 here, and B is 0 here. So they're in 2 rows where B is 0. And then, so let's just write that. So it's B not already. We know that for a fact. And then what else is true? At the same time, they're all at D is 0 as well. So when this is 0, that's when all these fall into the category. So we have not D. And there you go. That's our midterm for this, our minimized equation for this. So what we just went over is given like a pretty complicated long midterm filled equation. We can simply just create a 4-variable K-map and literally just plug in our values for the midterms, and then use our intuition and skills. Like once you do a lot of examples, you'll see all these cool tricks you can do with K-maps. Like I'll go over some right now with a different color. So like imagine, so we went over this square one right here, this square, this type of this is the most complicated one, I think, in my opinion, where you have 1 on each corner. You can have one like this where it's going through all of them, simply 2 going that way. And remember, any overlap is okay. Actually, overlap is better because you're covering more ground. It actually makes more sense. Just make sure, one thing, I'll write this in, let's do this in pink. You never want to do this. You never want to create one by itself, such as this. You never want to create, this is kind of messy, but hopefully you're listening and getting the point across. You never want to do 3 in a row. You definitely don't want to do something like this, because it doesn't make sense. First of all, you won't find a good correlation between the 3 blocks that you circled, and it's just how K-maps are structured for that not to work. So in general, this is pretty much how to, given a truth table or given a function full of minterms, how to make a K-map and how to get a reduced equation out of it. And then from this, you can easily make a circuit. I'll go over that in my other video about circuits, or you can look one up. I hope you guys found this helpful, and check out my other videos. Thank you.